Hello everyone, this is Mrs. Hanin Khair from Al Shumuq International School. In this video, we are going to cover the last part of the last topic of grade 12 syllabus, electrolysis. So what is electrolysis? Any ionic compound conducts electricity when it's molten or when dissolved in solution. The current causes the ionic compound to split up and form new substances. This process, the process of splitting an ionic compound into its original substances, it's called electrolysis. The word means splitting by electricity. If the terminals are connected to an external voltage supply and the applied voltage is gradually increased until it exceeds the E of the cell, the current flows in the circuit and electrolysis takes place. So therefore, the minimum voltage, the minimum applied voltage should exceed the E of the cell, the E0 of the cell, which we have studied in previous videos. So as you can see, we have a DC current, a direct current. This is the voltage supply. We have the cathode, the anode, and this is the electrolyte, which is either a molten ionic compound or an ionic compound dissolved in water aqueous solution. During electrolysis, electrodes are reversed compared to the electrochemical cell. So the positive electrode is the anode and the negative electrode is the cathode. The electrodes themselves are pieces of carbon or inert metals. They are connected to a DC power supply. An electrolyte is a compound which undergoes electrolysis. Electrolytes must contain ions. Cations go to the cathode. As you can see, there is a similarity. Cations migrate to the cathode. Cations are positive ions. They go to the cathode, the negative electrode. Anions go to the anode, which is the positive electrode. As you can see here, you have a molten PbBr2. So the positive ions are going to the negative electrode. The cations are migrating to the negative electrode or the cathode, and the anions are migrating to the anode or the positive electrode. At the cathode, the cations gain electrons. This is reduction. At the anode, the anions lose electrons. This is oxidation. So any ionic compound that is made from charged ions cannot conduct electricity when in the solid state. It has to be molten or dissolved so that the ions can move. When you melt an ionic compound, the ions are free to move, so therefore they can conduct electricity. Same thing when you dissolve an ionic compound in water, the ions are free to move and therefore they can conduct electricity. We will start by electrolysis of molten electrolytes. What redox processes occur at the electrodes during the electrolysis of molten lead bromide PbBr2? At the negative electrode or at the cathode, Pb2 plus ions are going to migrate. So Pb2 plus ions will gain 2 electrons, will be reduced at the cathode to form Pb solid. At the positive electrode or at the anode, the anions will migrate. Br minus ion, each Br minus ion will lose 1 electron and Br2 is formed. So 2 Br minus forming Br2 plus 2 electrons. This is oxidation. The overall reaction is you're going from lead bromide into the elements that are lead and bromine. So you're splitting the compound PbBr2 into its natural elements Pb solid and Br2 gas. So as you can see here, this is the apparatus used in electrolysis. This is the molten lead bromide in here, And as you can see, at the negative electrode or at the cathode, you have lead formed. And at the positive electrode or at the anode, you have bromine vapor, Br2 gas is formed. This is the power, the battery is the power supply, and we use the bulb just to indicate that current is flowing indeed. The heat used, the heat supply below the beaker is used to keep the PbBr2 in the molten state. For every Pb2 plus ion discharged, the word discharged means losing its charge. So cations are discharged by gaining electrons, anions are discharged by losing electrons. Cations gain their electrons at the cathode, and anions lose their electrons at the anode, and the power supply acts as a pump that pumps the electrons along the wire to fill up the gaps appearing in the cathode. So at the cathode, the supply of the electrons should be continuous so that cations are gaining electrons, and it pumps away the new electrons being released at the anode so that the electrons are not accumulating at the anode. Conductivity often increases as the temperature increases. This is because there is less viscous drag on the ions. The ions can move more freely, they can conduct electricity better if the temperature is higher. Electrolysis of molten electrolytes is used basically to form reactive metals that, if water is present in the medium, they will directly react with it. Application: write the half equations of the following electrolysis. So I am electrolyzing PbI2. At the anode, anions are present. So I minus will go to the anode, where 2I minus will lose 2 electrons to form I2, whereas at the cathode, cations migrate and they are reduced to Pb. So Pb2 plus Pb plus 2 electrons form Pb. The liquid state indicates that the PbI2 is in the molten state. Now we have to start electrolysis of solutions. Water itself is a very weak electrolyte because it splits into a very small extent into hydrogen and hydroxide ions. So the amount of the ions present in water, pure water, is very low. However, they are still present. I have H plus ions and OH minus ions. This means that more than one ion arrive at each electrode. So you have NaCl solution, you have Na plus ions coming from the NaCl and H plus ions coming from water. Both these cations will migrate to the cathode. You have chloride ions from the NaCl and hydroxide ions from water. Both of these ions are going to migrate to the anode, where competition takes place between these ions. Selective discharge. The ease of discharge of cations will depend on the position of the metals in the reactivity series. The more reactive the metal is, the least the tendency of the metal ion to be preferentially discharged at the cathode. So we already explained before that if a metal is very reactive, its reducing power is very high, its metal ion is going to be unreactive and its oxidizing power is going to be very low. So, a cation coming from a metal which is below hydrogen in the reactivity series will be preferentially discharged. A metal will be produced then. So if the metal is below hydrogen in the reactivity series, the metal ion will be reduced instead of hydrogen ions. However, hydrogen ions will be preferentially discharged over the ions of the metal, over the cations, if the metal is above hydrogen in the reactivity series, and in this case, hydrogen gas will be produced. So as you can see, this is the reactivity series. The reducing power increases as the value of the E0 becomes more negative. Lithium metal is the most reducing agent, the most powerful reducing agent, whereas lithium ions is the weakest oxidizing agent. So therefore, Metals such as Pb, nickel, cadmium, Fe, zinc, if you are doing any electrolysis reaction involving any metal that is more reactive than hydrogen, the metal is more reactive than hydrogen gas, then hydrogen ion will be more reactive than the cation. So therefore H plus will undergo the reduction instead of the cation. However, let's consider Cu. Cu is less reactive than H2, as you can see in the direction of the blue arrow. So Cu is less reactive than H2. However, Cu2 plus ions are more reactive than H plus ions. So if the electrolysis includes Cu2 plus ions, Cu2 plus ions will win the competition over hydrogen ions, and reduction of Cu2 plus will take place at the cathode. Now what happens at the anode? The ease of discharge of anions increase down the list. As you can see, you have the anions SO42 minus, Cl minus, Br minus, I minus, hydroxide. Now the most reactive anion is the hydroxide. Basically, hydroxides will be always preferred over any other anion. Nitrates and sulfates can never be oxidized during electrolysis. Hydroxide ions has the highest ease of discharge because they can undergo oxidation really easily. If hydroxide ions undergo the oxidation at the anode, then oxygen gas will be produced. The half equation of the discharge of hydroxide ions is given below. 4 hydroxide ions are going to lose 4 electrons to form 2 water molecules and an oxygen gas. It is important to note that if the anion is present in high concentration, this highly concentrated anion will undergo the oxidation regardless the ease of discharge. Basically, we're talking about halides, Cl minus, Br minus, I minus. If these ions are present in high concentration, then these ions will undergo oxidation regardless the presence of hydroxide ions and the ease of its discharge. In concentrated solutions, we have a lot more halides than hydroxide ions. Therefore, halides undergo oxidation preferentially to hydroxide ions. Let's consider several solutions. We'll start with concentrated NaCl. The ions present in NaCl, sodium ions and sodium ions are antichloride ions. The sodium ions and the hydrogen ions from the water are both attracted to the cathode. Chloride ions and hydroxide ions, again from water, are both attracted to the anode. So as you can see, the competition at the cathode is between Na plus and H plus ions. The competition at the anode is between Cl minus and OH minus ions. At the cathode, the two cations are Na plus and H plus ions. Considering the E0 values of these two couples, redox couples, we can see that Na is more reactive than H2 because it has a more negative E0 value. And H plus is more reactive than Na plus according to the reactivity series. So since the E0 of H plus H2 is 0, it's more positive, then H plus ions are more or are greater oxidizing agents, stronger oxidizing agents than Na plus ions. H plus ions will win the competition at the cathode. They will undergo reduction rather than sodium ions, and hydrogen gas will be produced according to the equation 2H plus 2 electrons forming H2 gas. At the anode, the anions are Cl minus and hydroxide ions. In concentrated NaCl, there are a lot more chlorides than you have hydroxides. So therefore, chlorides will undergo the reduction over the hydroxide ions, and 2Cl minus losing 2 electrons will form Cl2. So what are the observations? At the cathode, hydrogen gas will be released. At the anode, Cl2 will be released, and NaOH will remain in the solution. So as you can see, this is NaCl. When you do electrolysis of NaCl at the cathode, you will have at the cathode you will have hydrogen gas, and at the anode you will have chlorine gas. What's left in the solution are the Na plus ions coming from NaCl and OH minus ions coming from water, so a sodium hydroxide solution forms. The second example we will encounter is concentrated NaOH. At the cathode, the cations are Na plus from NaOH, H plus from water. Comparing again the A0s, you will see that the A0 of H plus H2 is more positive, therefore H plus will undergo the reduction instead of Na plus, so hydrogen gas will be obtained at the cathode. At the anode, there are only OH minus ions. From NaOH I have OH minus, from water I have OH minus, so therefore there is no competition and hydroxide ions are discharged at the anode. Oxygen gas will be obtained according to the following half reaction. 4 OH minus forming 2 water, oxygen gas and 4 electrons. So in electrolyzing NaOH, the following is observed. At the cathode, hydrogen gas is released. At the anode, oxygen gas is released. So this is the sodium hydroxide, and we have the platinum electrodes. Any inert metals can act as electrodes. Hydrogen gas is obtained at the cathode. Oxygen gas is obtained at the anode. The last example we are going to consider is concentrated H2SO4. At the cathode, the only cations are H plus coming from H2SO4 and from water. So therefore H plus will be reduced at the cathode according to the equation. 2H plus 2 electrons forming hydrogen gas. That's at the cathode. At the anode, there are 2 ions, SO4 2 minus coming from H2SO4 and OH minus ions coming from water. Hydroxide ions has the highest ease of discharge, therefore they are preferentially discharged over sulfate ions, and oxygen gas will be produced at the anode according to the half reaction studied before. So in electrolyzing H2SO4, the following is observed. At the cathode, hydrogen gas is released. At the anode, oxygen gas is released. And this is the scheme showing what's happening. This is sulfuric acid. And you have the positive electrode, which is the anode, the negative electrode, which is the cathode. And the products are hydrogen gas and oxygen gas. That's everything for electrolysis. Thank you for watching.